Welcome to our podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore how cosmic particles uncover volcano secrets. The next time the sun is shining, go outside. There may not be a cloud in the sky, but you will be standing in the middle of a spectral rainstorm. Cosmic rays, emanating from all sorts of high-energy entities, constantly bombard Earth's atmosphere. Their collisions with gases make tiny particles named pions, which speedily decay into muons, subatomic blobs more than 200 times heavier than electrons. Trillions of muons are shooting toward the ground at close to the speed of light every single second. When muons encounter an object, some pass right through while others get stopped in their tracks. That means muons can be used to see inside things that would otherwise be inaccessible, from nuclear reactors to the depths of Egypt's pyramids. Scientists have long suspected that this technique, named Muography, could be applied to volcanoes, whose anatomies determine when and how they will erupt. And researchers show in a paper, published Wednesday in the Proceedings of the Royal Society A, that muons have been used to successfully map out some of the arteries and organs of volcanoes across the world, including some of the world's most hazardous magmatic mountains. One day, volcanic muography could become the ultimate detection system for magma, said Giovanni Leone, a geophysicist at the University of Atacama in Chile and the study's lead author. He and his colleagues say that if you can use muons to track the movement of molten rock in real time, you should be able to forecast when an eruption is about to transpire. When muons zip through material, their momentum is sapped. The denser the material is, the more likely these muons will lose all their energy, grind to a halt, and decay into neutrinos and electrons. Objects are rarely equally dense throughout. That includes volcanoes, which are made of either magma-filled or vacant passageways, a diversity of rock types, and countless cracks, crevices, and chasms. To perceive these features, volcanologists could use muon detectors, which range from the size of a suitcase to the area of a small apartment. Scientists could place detectors around the flanks of a volcano, or even fly one around the volcano with a helicopter. The endless muon rainstorm will shower the volcano at an angle. Some of the muons passing through one side of the volcano's flanks will reach detectors on the other side. Those that don't will cast subatomic shadows on the detectors, revealing which parts of the mountain's insides are denser and which are more vacuous. With one detector, you can get a two-dimensional image of a volcano's innards, similar to a medical X-ray, said David Mahon, a muography researcher at the University of Glasgow, who was not involved with the study. By using multiple detectors positioned around the object, it's possible to build up a crude 3D image. After using muography to see inside an innocuous Japanese mountain in 1995, the technique was eventually deployed at active volcanoes. One of the first successful campaigns was Mount Asama in Japan, where researchers found a buried lava mound sitting atop a Swiss cheese-like magmatic passageway. It has since been used to see into, among others, Italy's Etna and Stromboli volcanoes, Japan's hyperactive Sakurajima volcano, and the La Soufrière de Guadeloupe volcano in the Caribbean. Muons have found weaknesses that hint at the site of future flank collapses, landslides, and lava escape routes. They have also found fresh pockets of magma that may be primed to erupt, and that were overlooked by other instruments. Volcanic muography isn't flawless. The detectors can only see the parts of the volcano that the muons are penetrating. You can only watch from below towards the sky, said Marina Rosas Carvajal, a volcano geophysicist at the Paris Institute of Earth Physics, who was not involved with the study. Muons cannot penetrate deeper parts of the volcano, leaving those areas largely off-limits to muographers. Placing detectors around dozens more volcanoes and subjecting volcanic rocks to muons in laboratories will improve the technique's precision as it vies for mainstream use. But even if it does become commonplace, it won't solve all our volcanic woes. Volcanoes are super complex, said Rosas Carbajal. Their labyrinthine innards and complex chemistries mean their magma will occasionally evade even the savviest detectors. Unpredictable eruptions will remain a fact of life, no matter how well scientists wield the magic of muons. And Muography is unlikely to make obsolete the other instruments used to study volcanoes, like seismic waves and satellite observation. It may not replace existing techniques, said Vitaly Kudryavtsev, a particle physicist at the University of Sheffield who was not involved with the study, but it may complement them. Thanks for tuning in to this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.